In part 1, we saw that when we divide two integers, processing throws away any fraction in the result and gives us back another integer, even if we save the result in a float. One way to tell processing to keep the floating point result is to include a float in the calculation. So in this little program, in the next to last line, I inserted a multiplication by 1.0. So let's go ahead and run this and see if we get 4.5. And sure enough, we do. So you will see me do that all the time. Mathematically, it doesn't help much. Multiplying something by 1 doesn't change its value. But in this case, multiplying I9 by 1.0 turns I9 into a float. Now, there's one gotcha I want to show you. Let's suppose that we want to do this twice. So I'm going to take this little expression, and I should probably change the name of the variable, but I won't. And I'm going to wrap it in parentheses, and I'm going to add it to itself. And now I'll just paste it. Oh, I need the parentheses as well. So now what have I got? Well, this is going to work fine. So let me break it for you. And I'm going to take out the times 1.0 on the second set of parentheses. So let's run this and then talk about what it's doing. So what I expect is 9 over 2 plus 9 over 2. 4.5 plus 4.5, it should be 9. Let's run it. And we only get 8.5. Why? What's going wrong? Well, when processing evaluates what's inside this first pair of parentheses, it says I have an integer and a float, and I'm dividing it by an integer. Great, that's a float. When it evaluates what's inside this pair of parentheses, it's not paying attention to anything else. It just says, I'm now doing whatever is inside a pair of parentheses. Oh, it's an integer over an integer. I'll compute that, 4.5. Oh, I'm dividing two integers, throw away the 0.5, now I have 4. And then it gets around to saying, oh, and I'll add that to the 4.5 I had in the other place. So the second pair of parentheses turns into a 4. The other one's 4.5. We get 8.5. So we need to multiply this by a float. So I'll tell you what, I'm going to multiply I2 by 1.0. So I'm just going to write 1.0 times I2, sticking it there just underneath the I9. And everything should work fine, right? So let's go ahead and run this and make sure it all comes out right. And whoa, things went seriously wrong. That should be 9, and it's 22.5. What the heck? Remember our discussion about the order in which processing executes the various mathematical operations that we give it if we give it more than one. Here I have a division and a multiplication. So what I wanted to do is to multiply 1 times I2, and then it's going to be I9 divided by that. But it just so happens that it's doing the slash first. So it's taking I9 divided by 1. Well, that's 9 over 1. That's just 9. And then it's multiplying that by 2, which gives us 18. And then it adds 4.5 to that. So I need a pair of parentheses around here. And you'll often see me, when I multiply by 1.0, putting a pair of parens around things. So now if we run this, things work out fine. The reason why everything is okay on the right-hand side now is 1.0 times I2. Well, I2 is just the number 2. So then inside this parentheses, we get the value 2.0, which is a floating point number. And now we have I9 divided by a float, and everything works out nicely. So just for clarity, I will put parens around this guy on the left-hand side. So now both of these are doing the same thing. They're both computing I9 divided by I2, but they're getting a floating point number in there somewhere. So if I run this, I should now get 9. So if you were doing something like this in a piece of animation, and you were computing I9 divided by 2, and you got 4 instead of 4.5, your animation might look like it was stuttering or jumping, or things might grow in little popping steps. And if that's happening for you, one place to go looking is to see if you're ever dividing an integer by an integer and getting back an integer instead of a float. This only applies to division. Addition, subtraction, and multiplication, this is not an issue. It's only an issue when you divide an integer by an integer. So it's a weird little gotcha, but if you keep that in mind, you'll be fine. And you'll see that in my code, I liberally sprinkle around these 1.0s. In fact, most of the time, any values that I think I'm going to be using in a little expression like this, I'll make them floats if I can. And I restrict my ints to only when I need to count things. But sometimes I'm counting several things, and I need to divide one of my counters by another and get back a floating point number. And when I do that, I make sure to multiply something in there by 1.0. The time where this whole subject is going to be of real importance to you is when you're animating using a system variable called frame count. This is a variable the system maintains for you. It's almost like a giant clock, and it tells you where you are in your animation. There's a whole video on frame count. The reason for mentioning it here is that frame count is an int. And you'll see that we do all kinds of things with frame count, again, because it's our clock. We add to and subtract from it, we multiply by it, and we divide it by different values. And if you divide frame count, which is your system clock, by an integer, you're going to get back integers, not floats. And that's why I'm bringing it up here, so that when you do start animating, you'll know when you start dividing frame count by numbers, you want those things to be floating point numbers.